Now, there is a problem by benzaldehyde undergoes condensation reaction with the hydrazine or nucleophilic addition reaction with the hydrazine or any derivative of ammonia like hydroxylamine, phenylhydrazine, etc. Now in benzaldehyde there is resonance like this. We get a canonical structure like this where there is charge separation. So due to this charge separation, this canonical structure contributes less to the resonance hybrid, so that the pi bond character here will be less, so that the electron density around this carbon will be less. Now in benzoic acid also, there is a similar resonance like this. We get a charged structure in which there are positive and negative charges, charge separation we say. Now it is similar to this structure, so that contribution of character of this canonical structure will be less. But in the case of benzoic acid, there is another resonance where this lone pair is given for bond formation, and there is shift of this electron pair here, so that the electron density around this carbon is still more increased than in the case of benzaldehyde. And suppose hydrazine molecule attacks the carbonyl carbon of benzoic acid, we get NH2 positive O negative. This bond polarizes, this lone pair is given to this carbon. Now then this H positive from here, NH2 positive goes to O negative, so I get OH, NH, NH2. And here we have a collection of groups with electron pairs, lone pairs, so around a small carbon atom, repulsion can occur. And since this group is a bulky group, the system will try to eliminate this bulky group so as to decrease the steric repulsion. So in presence of acid, this reaction happens, so that H positive will preferentially go to NH. We get NH2 positive, NH2. And then a molecule of water will take up H positive from here, so that this O bond will be shifting in this direction. Valence of carbon increases, and this is removed as NH2, NH2, and we get the free acid and the hydrazine. So there is no chemical reaction with the hydrazine except an acid-base reaction where COOH, H positive gets connected to NH2 through its lone pair on nitrogen, so that we get NH3 positive, NH2 and COO negative, that is salt. Now from esters we can prepare acid by hydrolysis. Now their alkyl group is the C2H5 group, and this molecule is ethyl benzoate. Alkyl to oxygen bond, alkyl to oxygen bond is broken. A molecule of water is also broken, oxygen getting connected to hydrogen and C2H5 connected to OH, so we get benzoic acid and C2H5OH. In acid medium, the reaction is reversible because the carbonyl carbon is more electrophilic. That is because in acid medium, the free acid is present as the final product, and there is a resonance, this lone pair shifting over this position to get a pi bond here, and this pair of electron moving over to oxygen atom, giving this canonical structure. And this, since this is a structure where there is charge separation, the contribution of character of this canonical structure will be less, so that there will be less pi bond character, so the electron density around this carbon will be less, so that it will be easily attacked by this nucleophile, that is alcohol, and the reaction is reversed. Whereas in basic medium, the acid formed will be reacting with the base to produce the salt, and we get carboxylate anion, and it is also a resonance hybrid where there is no charge separation, so this canonical structure is much more stable than this canonical structure, so that the pi character of this bond is much higher, so that the electron density around this carbon is higher, so it will be having a lesser tendency to react with the nucleophile. So in basic medium, the reaction is not reversible. Now properties: in the vapor state, it exists as a dimer, RCOOH and RCOOH. There are two hydrogen bonds, and it is existing as a single unit. Now lower alcohols are soluble in water due to hydrogen bonding between the acid molecule and water molecule, a stronger hydrogen bond forms between water molecule and the acid molecule. When we come to higher acids, the alkyl part becomes larger in size and higher in molecular mass, and the main force operating will be van der Waals forces. And since water is a polar medium, the non-polar part will not have any attraction towards water molecules, so the van der Waals forces will not operate between water molecules and the high molecular weight and the highly sized alkyl part, so that the higher acids are insoluble in water. Now coming to the chemical properties, acidity with sodium hydroxide and sodium bicarbonates. With metallic sodium we get hydrogen as one of the product and sodium salt of the acid. And with sodium hydroxide, a base, salt and water are formed, RCOONA plus H2O. And with sodium bicarbonate, this reaction is specific. It is used as a test for carboxylic acids. We get carbonic acid and sodium salt of carboxylic acid, RCOONA, and H2CO3. H2CO3 will decompose giving H2 and CO2, and CO2 will be emerging as a gas, and it is called a brisk effervescence of carbon dioxide. Now what is done is you prepare a solution of sodium bicarbonate and add the solid acid. Benzoic acid is a solid, add this acid to the medium. It will be floating on the surface and you will see bubbles of carbon dioxide below the particles on the surface. And if the acid is a liquid like acetic acid or formic acid, you will see the brisk evolution of carbon dioxide. So it is used as a test for detecting acids. Now acid strength of carboxylic acids. Electron withdrawing groups will increase the acidity of carboxylic acids. There is a particular equilibrium between RCOOH and RCOO negative and H positive, and the equilibrium constant is called Ka. That is concentration of RCOO negative into concentration of H positive divided by concentration of RCOOH. And here as K increases, concentration of H positive increases. And there is another parameter called pK, that is minus log Ka, that is log 1 by Ka. So as Ka increases, 1 by Ka decreases and pK decreases. So that as Ka, that is concentration of H positive in the time Ka increases, concentration of H positive in the time increases, and so the acid strength increases and pK decreases. So electron withdrawing groups will withdraw electron density. R is an electron withdrawing group, suppose, then it will withdraw electron density like this, so that electron density around the oxygen atom is decreased. So the oxygen atom will strongly pull the electron pair between oxygen and hydrogen, so that there is a greater chance for removal of H as H positive, increasing the acid strength. Conversely, electron donating groups will increase the electron density around this oxygen atom, and this oxygen atom will be having a lesser tendency to pull the electron pair between O and H, so that removal of H as H positive is made difficult, so that concentration of H positive decreases, K decreases, and as K decreases, 1 by K increases and pK increases, so that an acid with the higher strength will be having a lower pK, and acid with lower strength will be having a higher pK. Now study this sequence: C6H5 less than I, less than Br, less than Cl, less than F, less than Cn, less than NO2, and less than CF3. Now this is a sequence in which electronegativity of the group increases. Now cyanide, CNC, triple bond N. Triple bonded carbon and triple bonded nitrogen are much more electronegative, and their combined electronegativity exceeds that of fluorine. So Cn minus is an electronegative group, more electronegative than fluorine. And when we come to NO2, we have N positive double bond O O negative, and since it contains 3 most electronegative atoms and a positive charge and again a double bond oxygen atom, it is much more electronegative group than cyanide group. And when we come to CF3 group, there are 3 fluorine atoms which are much more electronegative than NO2 because of the abundance of fluorine atom, which is highest electronegative element. Now consider this acid. It's called acrylic acid. ACRYLIC, acrylic acid. Now it contains a vinyl group, CH2 double bond CH. There is resonance. This bond shifts its direction and this bond shifts in the direction of oxygen atom, giving a positive charge here and O negative here. So we say due to resonance, electron density is injected into the carboxylic acid group. So electron donating group, and hence there should be a decrease in pK. But the CH2CH group shows a minus effect. So this carbon is sp2 hybridized, and sp2 hybridized carbon is more electronegative than sp3 hybridized carbon, and so this minus effect slightly withdraws the electron density along the sigma bond. So it is not as lower in acid strength as propionic acid. The pK values of propionic acid and acrylic acid are given here. For acrylic acid it is 4.26, and for propanoic acid or propionic acid it is 4.87. So acrylic acid is stronger than propionic acid because it possesses a lower pK value, and that is due to, we can say, minus effect of the vinyl group. But again, propanoic acid is having a higher pK value or lower acid strength mainly due to 2 reasons: the plus effect of ethyl group and hyperconjugation of CH2 group. The CH2 group here, CH bond will be shifting like this and CO bond will be shifting like this, so that we have hyperconjugation canonical structures like this. So compared to acrylic acid, propanoic acid is having a higher acid strength, and that is due to hyperconjugation as well as plus effect. So minus effect alone cannot be considered as the reason for the higher acid strength of acrylic acid or propanoic acid. We have to consider the plus I and hyperconjugation of propanoic acid also. Now coming to some aromatic acid, that is para-methoxybenzoic acid and benzoic acid, and then para-nitrobenzoic acid. Here methoxy group with its lone pair or oxygen atom shows plus mesomeric effect, that is pushing electron density, injecting electron density, donating electron density to the ring, and then through the ring to the carboxylic acid group, so that the electron density around the oxygen atom in the OH group is increased due to plasma effect of methoxy group, so that this oxygen atom will be showing a lesser tendency to take up the electron pair in the OH bond. So the acid strength is decreased. Its pK value is found to be 4.46, and that is higher than that of benzoic acid, where the para position is occupied by H, and it shows no M effect, or its I effect is practically 0. So benzoic acid is stronger than para-methoxybenzoic acid, whereas when we come to para-nitrobenzoic acid, nitro group shows minus I and minus M, that is highly electron withdrawing in character. So we can say the OH group will be showing a higher tendency to ionize into OH, O minus, and H positive. So its pK value is found to be lower than both para-methoxy and benzoic acid, 3.41, and the main reason is electron withdrawing character of nitro group, that is minus I and minus M. Now formation of anhydride with the P2O5, RCOOH, RCOOH, removal of HOH, RCOO, COR, Now it is affected with phosphorus pentoxide. Phosphorus pentoxide will absorb water and form phosphoric acid P2O5 plus 3H2O giving 2H3PO4. Now there is another particular reaction called esterification reaction, that is formation of ester from an alcohol and a carboxylic acid in presence of concentrated sulfuric acid or HCl gas. You write the equation as RC double bond OH, then ROH, then OH of acid and H of alcohol combined to form water to give RCOOR. Now this reaction is catalyzed by acid, and the mechanism is given. First of all, the acid donates H positive, and since there is resonance in the COH group where this lone pair is given to bond formation here and this CO bond ionizes, there will be a partial positive charge over this oxygen and partial negative charge over this oxygen atom. So H positive gets connected to this partially negative oxygen, we get OH positive. Then the alcohol, which is acting as a nucleophile, will attack this carbon. There is simultaneous shift of this pair of electron, and we get ROH positive, and this OH bond will be shifting over this oxygen atom, means this pair of electron will be taken up entirely by this oxygen. Its positive charge gets neutralized, and then H positive will be getting connected to any one of the OH groups through the oxygen atom. Lone pair of oxygen, OH2 positive is formed. Then the lone pair here will be shifting, and the valency of carbon increases, so that this bond will be shifting over oxygen. The positive charge over oxygen atom is neutralized, and it is removed as a molecule of water, and so you get double bond OH, and this removes a proton H positive, and these reactions can be reversed through these steps, and we get this acid and alcohol back. So it is a reversible reaction. Then acid halides are formed when an acid reacts with the PCl3, PCl5 or SOCl2, 3RCOOH. This OH group behaves as the OH group in alcohol. PCl3 gives 3RCOCl and H3PO3. RCOOH plus PCl5 gives RCOCl plus POCl3 plus HCl, as in the case of alcohol. RCOOH plus SOCl2, RCOCl plus SO2 plus HCl. Now reaction with ammonia, we get the ammonium salt because ammonia is a base. So H positive from acid is absorbed by ammonia to give ammonium ion, and this one heating gives the amide. Now ammonium ion is in equilibrium with ammonia and H positive. Now ammonia will attack this carbonyl carbon, and we get RCO negative and H3 positive. That then H positive is removed with OH. Then H positive is getting connected here. So H2 positive is removed as a molecule of water. This O negative shifts here, and we get CH3CONH2. So that is amide formation. On heating, these reactions happen. So you need not study this mechanism, but you understand that this on heating gives amide plus a molecule of water. Now one particular reaction is given in the text got to study, that is this compound is called phthalic acid, PHTHALIC, phthalic acid. With ammonia we get ammonium phthalate, which on heating the reaction similar to this one happens. We get CONS2 and CONS2, that is phthalamide it is called. You need not worry about the name. Now this on heating, further heating, a molecule of ammonia is removed, and this CO group connects to NH, and this molecule is called phthalimide. Now reduction using lithium aluminum hydride in ether or B2H6, that is diborane. RCOH is converted to RCH2OH. Now RCOH dissociates into RC double O negative and H positive. Now a hydride ion from aluminum hydride part is connected to H positive, H negative, and H positive will liberate hydrogen. and AlH3 and Rc double negative connected to Li positive. Now another hydride will get connected to the carbon with simultaneous polarization ionization. Here she get RCH, O negative, AlH2, and this AlH2 will get connected to O negative, so that we get OAlH2 part. Now then this lone pair over oxygen atom will shift in between this carbon and oxygen, creating a bond, so that this portion is removed as OAlH2 negative, because the balance of carbon has to be maintained. So we get RCHO, it is called aldehyde. So first stage reduction results in the formation of an aldehyde and OAlH2 negative, Li positive. Then OAlH2 negative donates one hydride to the carbonyl carbon with simultaneous ionization. Here we get RCHH, O minus, Li positive, and OAlH. Then RCHHO minus, Li positive with acid gives OH. If it is H positive, C negative, we should get LiCl. So that is the net reduction to RCH2OH. So simple reaction, simple mechanism. Now there is a particular reaction called the Volhard Zelinsky reaction. It is abbreviated as HVZ reaction. Now an acid containing alpha hydrogen atom, so that there should be an alpha carbon and there should be hydrogen atoms on this alpha carbon. So as a general example, we can write RCH2COOH. This is alpha carbon, there is hydrogen on alpha carbon, so there is alpha hydrogen will react with the red phosphorus and chlorine or bromine. We get RCHCl COOH or RCHBrCOOH. Now there is a complicated mechanism for this reaction. You need not worry about the mechanism. Now from this compound, if RCHClCOH is taken, RCHClCOH with the NaOH, we can say this Cl may be replaced to RCHOH COONA, which on acidification H positive we get RCHOH COOH. This is an alpha hydroxy acid, so such preparations are possible by Volhard Zelinsky reaction. So an alpha hydrogenated acid, an acid containing alpha hydrogen, on reaction with the heating with red phosphorus and chlorine or bromine, we get alpha chloro or alpha bromo. And if we are using excess chlorine, you can replace this hydrogen also to give RCCl2COOH. So let's complete here. Thank you.